Okay, here we hit problem 16 on the review. This one is the word problem, so I went ahead and just used the exact review and didn't use an extra piece of paper, so hopefully I have enough room here. So you deposited $8,500 in an account that paid 1.5% interest for 10 years. How much will you have in the account with the following compounded patterns? How much interest would you have earned? And so here it breaks it down: compounded monthly, daily, continuously, and then of course kind of a little continuation is how long will it take to double. So the key word here is monthly. And so if you see monthly, daily, semi-annually, then you want to use this formula. If you see the word continuously, that's your clue to use our continuous formula. And so here I'm going to go ahead and write it out and then show you how to put it in the calculator. And so here we're looking for how much will be. So we're looking for our future amount. So A equals 8,500. Parentheses 1 plus our rate changed to a decimal, so be careful. That's often a common mistake. 12 is monthly, and then N would be 12 again, since those are the same. How many years? 10 years. And so here is just, it's a simple calculator problem, except for it's a lot to keep up with. And so some key things when you're using a calculator is make sure that this is in a separate set of parentheses. Also, for my older calculators, it seems to be very sensitive on the exponent, so make sure you put all that into a parenthesis as well. And so let me kind of show you what I'm looking at here. And so here I typed it in. I'm going to put my exponent 12 times 10. And so this is what it looks like, and this is the answer I get. So for monthly, I get $9,874.67. Again, remember this was my future amount after 10 years with depositing an original amount of $8,500. That seems appropriate for that small interest rate over 10 years, compounding every monthly. And so then when we do the daily one, the daily one looks very, very similar. Again, be careful how you put it all in. 8,500, 1 plus same interest rate, but now it's going to say 365 over 365 times 10. Again, very sensitive on parentheses. So how do I do that in my calculator? I could always go second, hit the enter button. That's going to bring up exactly what I put in, but now I'm going to change all the 12s to 365. So that'd be 360. Now do an insert. That'll let me put in my 5. Go over here. My 12 needs to be 36. Go insert, add your 5. And so now you should be able to hit it. That's going to be my daily amount, 9,875.56. So what does this mean? It means if it was compounded daily as opposed to monthly, after 10 years, you'll have $9,875.56. So merely, a few cents off. So let's talk about continuously. Remember, I told you that's going to be your second formula. So it's A equals my principal, 8,500. E, my rate is still 0.015 times 10. And so how do we put that in our calculator? Let me find the placement for it. So here we would have 8,500, and then you'd go to your E button, which is second, natural log. That'll bring it to E, with allowing you to put your exponent is 0.015 times 10, all happening in the exponent, hitting enter. And so we get $9,875.59. Not much difference from the daily. And so all of these should be fairly close together. We kind of explored with this in class, and we discovered that, how often it gets compounded in a year doesn't seem to change too greatly. So if you get one that's really way off, then something happened in your calculator. So let's look at the last part of 16. Let's look at where it says, how long will it take to double your money? So in this case, you're looking for time. We're not using 10 in this problem. And so we do have to kind of think of the concept of doubling our money. So if I wanted 85 to double, that would essentially be times 2. And so now my future amount is 17. And it says if you compounded continuously, again, there's your clue, your keyword, compounded continuously. So we're going to be using this formula that goes with continuous. So I have 17,000 equals my original principal, 8,500. E, because I'm using continuously, I have that same rate, but now I don't know time, I don't know t. And so now we essentially need to solve for a variable that's trapped in an exponent. And so that's kind of my clue here, is whenever a variable is trapped in an exponent, I'm going to have to do some kind of rewriting. I'm going to have to use the inverse to free it. So the first thing I'm going to do is I'm going to divide both sides by 8,500. It's no surprise that we get 2 equals e to the 0.015 t. So you have to isolate whatever is being raised to the variable that's being trapped. And so here I have 2 equals e to the 0.015 t. I need to free t somehow, and so the only way to do that is to rewrite in logarithmic form. So the log, or we use natural log since my base is e, so I get natural base e. I don't need to write the e, it's implied. Remember, log is always equal to my exponent, so in this case 0.015t would be on the other side since that's my exponent, so it must be 2 goes here. So now look, I've freed up my t. Only thing left to do is divide both sides by 0.015. 0.015. And so now it becomes simply a calculator problem. I'll show you how to put it in the calculator. So come over here to your calculator. It's going to be natural log, let me clear all this so you don't get, natural log of 2 divided by 0.015, and so we hit enter. And it looks like it's going to take me approximately 46 years and some days, because it says 46.20, it's not quite 25. So it's going to be approximately 46 years before it will double if it stays at that interest rate and it's compounded continuously.